Functional groups are the heart and soul of organic chemistry. You have to recognize them, you have to learn their names. So this presentation is all about functional groups.
So let's look at the classes of compounds first. Classification of compounds in organic chemistry is based on functional group, and a functional group is where reactions usually will take place. If there is no functional group, then generally the compound is very unreactive. Okay, so for example, alkanes don't really have a functional group, and so they are the least reactive. However, we do classify alkanes as a functional group, not because of their reactivity, but just because it puts them in a category. Okay, and so they are just a class of compounds. There are three broad classes or categories of compounds. One, which are just plain hydrocarbons, which means containing hydrogen and carbon. Then we have compounds containing oxygen, and then compounds containing nitrogen. It doesn't really mean that you don't have compounds containing oxygen and nitrogen, or vice versa, or hydrocarbons or halogens, but these are just some of the easier classifications to do. So we classify them like this and we learn them like this, and then you apply it to different compounds. Organic compounds are also classified as aliphatic and aromatic. Aliphatic is straight chain compounds, and aromatic are like benzene rings. Okay, and benzene ring is probably one of the most identified molecule of organic chemistry. It's very easy to recognize. So anyhow, those two are also classifications. Typically, you will not see it that much. You will see the other classifications a lot more. Um, and finally, functional groups are also classified as families. So as I mentioned to you, alkanes, we kind of just say it's a family because they don't really react very much. So not a functional group, but just a family. And then there is a homologous series. In the homologous series, what you have is a series of compounds which are increasing by one carbon. Okay, that's it. You start wondering, how is organic chemistry so big? And it is so big because each of these classes of compounds have so many compounds in them. Okay, and so that is defined as a homologous series. Okay, so as we go on further and further, you increase the number of carbons in that particular family. The nomenclature in organic chemistry is very systematic. There's general names also, which we will learn about, but otherwise, if you follow the most systematic nomenclature, then you can tell very easily what kind of a compound you're talking about, which means what kind of functional group you're talking about, and how many carbon atoms. Those are the two most important things in any kind of a compound. So if you follow the systematic way, then it's very, very easy. So this is how it goes with the number of carbons. It goes up to 20. I need you to know 1 through 10. So for one carbon, it's meth. Then for two carbons, eth. Three carbons, prop. And then bute, pent, hex, hept, oct, non, dec. This goes all the way to 10. So this just tells you the number of carbons in there. So the family name, okay, is how you would end any compound. So for example, an alkane functional group would end in ane, an alcohol functional group will end in -ol, an aldehyde will end in -al, and then -one is for ketone. Okay, and so for one carbon alkane, that would be methane. For a 4-carbon compound containing an alcohol, it would be butanol. And for 2-carbon containing aldehyde, it would be ethanol. It's a very systematic name, so you really cannot get confused with what kind of functional group we are talking about or how many carbons we are talking about. Again, just 1 through 10. Here are the different functional groups, and I want to take just a little bit time on telling you the key features of it. The rest of it, you have to memorize it yourself. There is no other way for it. For alkanes, it's all single bonds, okay? There's another chart I've uploaded for you on our class website, which has a little bit more details on it. This one has the structure, so I like this one also, okay? So make sure you print this one as well. Here we have alkane functional group, which is just CC bonds, single bonds, okay, between carbon and carbon. And here are some examples, okay, just one example, sorry, ethane. For alkene, you have a double bond in there, and here are some examples for it. For alkynes, there will be a triple bond. And here are some examples. Again, look at the names of all of this, okay? It kind of gives you a little idea how the nomenclature also works. Ethane, 2 carbons, eth, alkane, ane. Ethene for 2 carbons, alkene, okay? And so on. For aromatic, aromatic is a benzene-like ring. Now, benzene are not the only compounds that are aromatic, but this is the most recognized one, so we're going to talk about it now. But we will address this a lot more in organic too when we actually study our aromatic compounds in details. But for now, this is the only aromatic compound you know about. Haloalkanes is also a family, in which case one hydrogen from an alkane is replaced by one halogen. A halogen can be any one, fluorine, chlorine, bromine, whichever one. So that would be a haloalkane. An alcohol is when a hydrogen is replaced by an OH group. Um, do not confuse this with hydroxide. Okay, this is not hydroxide, this is an OH group. So that would be an alcohol. In case of an ether, that second hydrogen is also gone. Okay, this one hydrogen from alcohol is also gone, replaced by carbon. So an ether will look like a carbon, oxygen, carbon. That's how you should find an ether in any kind of a compound. So these are some of the first functional groups, okay, and we will do alkane, alkene, alkynes, and haloalkanes in organic 1. The rest we do in organic 2. Here's the next part, and let me talk about aldehyde first. We'll talk about amine in a second. Aldehyde, ketone, carboxylic acid, ester, and amide. If you look at all of these, they have a C double bond O. In the ether and alcohol, it was a C single bond oxygen. Here it is a C double bond O. These compounds are also called carbonyls. We can talk more about it later on, but for now, you just need to know that the C double bond O is a very different kind of a bond. And so aldehyde, ketone, carboxylic esters, carboxylic acids and esters, you will find the C double bond O in there. In aldehyde, this bond right here, C double bond O, is connected to a hydrogen. So this is what it looks like. In short form, it also looks like CHO. In case of a ketone, the ketone functional group, the C double bond O, is surrounded by 2 carbons. Okay, so which means it's in the middle. Okay, somewhere. Usually these kind of functional groups are called internal functional groups. Carboxylic acid is where the C double bond O is connected to an OH group. Okay, and carboxylic acids are the acids of organic chemistry, and you've seen these before in Gen Chem 2. So this is carboxylic acid. Carboxylic ester is when you take the acid and take the acidic proton out and add a carbon there somewhere, and or any number of carbons. It could be 1, 2, 3, whatever it is, but there's a carbon here. So here's the ester, okay, that you're looking at. So no hydrogen. Esters can be in the middle also because they are surrounded by carbons. The amide linkage has the carbonyl also, C double bond O, but then that C double bond O is connected to a nitrogen, okay, and so that's what makes an amide, okay, a C double bond O, N. That's what it should look like. Let me come back here to amine, and amines are where carbon is connected to a nitrogen, okay, that's what amines are. All of this stuff we will do in organic too. Nitriles is probably one of the least common functional group that you will encounter, okay, because C triple bond N, these compounds are not very common, and so we will probably talk about it more in organic too than organic. Here is an example of just functional groups, okay, drawing the line structures and all that, you really have to practice that separately. But here's an example of a functional group, okay, so you can have one big compound which can have many functional groups in it. Okay, so this one, for example, has an ester right here, C double bond O, then connected to the oxygen, which is connected to a carbon that makes it an ester. Here is an alcohol, OH. Here is a ketone, carbon, carbon with an oxygen, and then carbon. Okay, so that makes it a ketone. Here is a ketone, again, carbon, double bonded oxygen connected to a carbon and another carbon. Here's an alkene and here's another ketone. Okay, so here's an example for you.
From this presentation, you should learn all the functional groups. You have to memorize them. There is no other way. And I kind of went over some of the fundamentals of naming compounds. If you don't get it right now, it's okay. You'll get it in future because we have to do it anyway. But you must know all the functional groups.